Was Venus turned into hell by an ancient civilization? Why dark matter is not a theory? What's up with all the Great Attractor videos on YouTube? And in Q&A Plus, what's the current state of lava tube exploration? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. 999 Yape. Could Venus have had life in a civilization and then devastated their planet and exterminated themselves with greenhouse gases? I mean, the scale of the greenhouse gas release on Venus is beyond the ability of any civilization, even a really wasteful civilization, to be able to generate. I mean, when you're on the surface of Venus, you're experiencing more than 90 Earth atmospheres of pressure pushing down on you. It's a ludicrous amount of carbon dioxide in the atmosphere. And the only way that you could get this is if plate tectonics just shut down on Venus. So on Earth, we have plate tectonics. The plate tectonics draw carbon inside the Earth and sequester it away. As the plates grind under each other, they pull carbon in and then it's pulled out of the environment. But on Venus, the plate tectonics seized up, have stopped, maybe never happened. And so any carbon dioxide that was present on the surface, any carbon dioxide that went through volcanic outgassing was just there to stay and got thicker and thicker and thicker. So if we burned all the forests on Earth, found all the coal deposits on Earth, burned all the oil, it wouldn't be a fraction of the carbon dioxide than what they have on Venus. We can't cause a runaway greenhouse effect. We can only cause a regular, miserable greenhouse effect. One that makes our lives all just that much worse. Curtis Horn, what do you think of the video Dark Matter is Not a Theory by Angela Collier? That video from Angela is probably one of the most important videos that I've ever watched, and has deeply changed the way I discuss and describe dark matter, dark energy, and really anything that is a collection of observations. And, you know, if you haven't watched the video, you absolutely should, because she is tackling head on this really low energy attitude response that a lot of science communicators and scientists get from people who don't understand the search for dark matter and the search for dark energy and a lot of what astronomers do in general. And it's great because it's like the perfect clickbaitiest title ever, because she's saying dark matter is not a theory. And so someone who thinks like, yeah, dark matter is just this dumb thing, like scientists are just making this up and it's not a theory. And finally, a physicist is admitting this lie. And what she says is that it's not a theory. It's a series of observations. That what astronomers call dark matter is actually a large collection of individual, independent, well-performed, very accurate observations that tell us that there is some additional effect in the universe that we don't understand. That there is this disconnect between what the theories say, our understanding of gravity, and what we perceive out in the universe. And then people have tried to come up with ideas to explain how this works. And so in that video, she goes through the different methods that astronomers use to detect the presence of dark matter. And that some of these you could do with a small telescope. Like if you were willing to put in the time and you understood the science, then you could replicate the results. Nature is giving you the answer. Right? Nature is saying, here's the thing that you thought you understood, but you don't understand it. Go ahead, prove yourself. Great. And she goes through all of the independent lines of evidence that tell you that there is something there, that this mystery is real. Now, we don't know what the answer to the mystery is, but that's fine, right? Like that's not new, that there is a mystery and we don't know the answer to the mystery. That's how science works, right? That you uncover something new and unusual and then you have to work out what the answer is. And the analogy that I love to use is, that you're driving in your car and your car starts making a funny sound, right? You have made an observation. You know what your car is supposed to sound like, and now you've detected something new, an observation. And you are driving in the car with a friend and you ask your friend, you say, hey, do you hear that sound? And your friend goes, yes, I hear that sound. Okay, you have an independent party that has confirmed your observation. That is science. You make an observation, somebody with the same scientific equipment, in this case, a set of ears, makes the same observation. You know you're not a crazy person. Okay, great. Car's making a funny sound. Shouldn't be making the sound. You take it to a mechanic. So now you're trying to figure out why the car is making the funny sound. But no one argues that the car is making a funny sound, right? This is dark matter. No one argues that the universe is doing things that nobody anticipated, nobody expected, that galaxies are rotating too quickly. Stars are not orbiting in the way that you would expect. You're seeing invisible regions or blobs that are warping and distorting space-time. You can measure the effects in the cosmic microwave background radiation. These observations are real. And anyone who is willing to invest the time will understand those observations are real. And the fastest way to show that you don't know anything about it is to go, well, this isn't real. Physicists are just making stuff up to get a paycheck or whatever, right? Like, oh, great. Tell me you don't understand without telling me you don't understand. And so, back to the car analogy, you take your car to the mechanic says, yeah, I don't know what it is, but let's start with the wheel, right? Like maybe one of the wheels is loose or whatever. They pull off all the wheels, they check, put it all back, put in a different set of wheels. Car's still making the same sound. Okay, it wasn't the wheels, right? You had theory. And so in that case, maybe that is, well, maybe gravity doesn't work the way we think it does at the largest scales, right? Let's change the tires and see if that works. Nope. Still getting the same sound. Nope. New definition of gravity doesn't explain all of the observations made for dark matter. Okay, great. So then you keep going and say, okay, maybe it's transmission, fix the transmission, still making the sound. So like that is the physics saying, well, maybe it's neutrinos, right? That's a thing that we know. The neutrinos move close to the speed of light. They don't interact with regular matter. We know there's enormous amounts of this. Like there are hundreds of millions of neutrinos passing through your body every second. Hundreds of billions. Anyway, you don't even feel them, right? Because they don't interact with your body in any way. But they're real. And we know they're there. So maybe neutrinos could explain it. Well, no, the problem is that neutrinos are too hot. They move too fast. That you wouldn't get the clumping that you do with the gravitational lensing, the way you do with, if you had neutrinos. So it has to be something that is cold, something that is moving slowly. Okay. Back to your car analogy. You try another thing, right? And so we don't know what dark matter is, but the range of things that could explain the observations that have been made, they're running out of places to hide, right? It's got to explain all of these separate independent observations. It's got a lot of work to do. Whatever the theory is, it's got to be able to solve that. And we're down to really that there's some massive particle, slow moving, cold, massive particle that doesn't interact with regular matter or with itself, but it does produce gravity. Some versions of modified gravity, but that doesn't explain all the kinds of observations. And maybe primordial black holes or black holes of different masses can still explain it. It hasn't been totally ruled out, or some combination of a bunch of different potential particles. And it was great because you go back to Angela's video and you watch the comments, and the comments are just like not getting it, right? Like they literally just didn't listen to what she said. And either we're like, yeah, you're right, Angela, it's a dumb theory, it's not real. Or you don't understand, you dumb physicist lady. I have thought this through and have a general skepticism and pessimism for the scientific establishment. And therefore, I think this is another scam that is unleashed upon the regular world and the people who pay the salaries of these scientists who are just trying to scam us. You dumb lady. So it was amazing that you to follow on video where she just like patiently went through it again, but it just won't stick. So I think we kind of get to this place where we've done all we can as explainers. And so either you're off the train at this point. You're just like, you not only don't understand the state of the science and the astronomy, and you kind of don't want to. Like you just don't, like you're not interested. And that's fine. Right? It's not like the search for dark matter is going to cause you any personal issue. All right. And that's great. But like also stop obsessing about it. Like, why are you so obsessed about it? Like, why does it bother you so much that this thing that you don't understand and haven't taken the time to understand, but you're sure is wrong? When if you're willing to take the journey and understand the actual nature, the actual thing that astronomers understand, then you would probably be amazed and impressed and in awe and wonder at the fascinating mystery that nature, that the universe has laid out in front of us, that is going to keep people puzzling and busy for a while. And for the scientific community, they've got a range of really cool new toys that have shown up to help them get to the bottom of this mystery. So you've got the DESI survey, which we reported on last week. There's Nancy Grace Roman, there's Vera Rubin, there's the Euclid mission, there's James Webb. So there's a lot of great tools that have come online in just the last couple of years and or are coming in the next couple of years that are going to make it even harder for dark matter to hide. There are tons of experiments here on Earth, tabletop experiments in mines, in different countries, particle accelerators. People are trying to make dark matter in the lab, trying to rule out what dark matter might or might not be. And the progress is really exciting. And with this new range of tools, we should get an answer, right? So hopefully, and if not, then it's an even trickier problem, but the observations remain. So if you haven't already watched it, definitely watch her video. And again, one of the most powerful science explaining videos I've ever watched. Good job, Angela. You crushed it. It's time to shout out all the new $5 patrons and above. Staph Verhagen, Miguel Perendija, John Buddick, Jeff Mickelwaith, Greg Meeman, John Martin, Brad Hislop, Grumpy Dev, Walter R, and Jim Case. Join the club at patreon.com/universe today. Evo Love. Fraser, my imagination is terrified of the Great Attractor. Is this George Lemaitre's primeval atom vacuuming us back into the Big Bang? So there's something super weird about communicating concepts in space and astronomy, that somehow our knowledge about what is the current state of space and astronomy research stopped with Cosmos. Carl Sagan, Cosmos, 1983. That was the last time anyone spoke about what's happening in space and astronomy. And then there has been nothing else since then. And I guess YouTubers are looking back to the things that Carl Sagan was pondering, and maybe a little before that, maybe back into the 60s and the 70s, and then turning these into videos about things like the Great Attractor. And the problem is that astronomy, and like, this isn't you, like, I'm not putting this on you, but there is this man, like, we've been talking about this so much, and it blows my mind. Like, are we just not getting the information out very well? I don't understand. Like, sorry, like, it's not your fault. Like, I just gotta say, like clearly you've been watching media that has been telling you about the Great Attractor and making you nervous about, like, what is it? What could it be? Right? We know that galaxies are sliding towards something that's on the far side of the Milky Way. And what is that thing that is attracting all of these galaxies? What is this thing in the universe that we know of that can cause things to move towards other things? Gravity. And now we live in the realm of infrared telescopes, which are able to look through the gas and dust that is blocked by the center of the Milky Way. And so now astronomers have mapped out the thing that is the Great Attractor, and it is galaxies. That there are galaxies on the far side. There are more galaxies on the far side of the Milky Way. There's a bigger concentration of galaxies on the far side of the Milky Way. And because there is more mass concentrated that just happens to, like, coincidentally happens to be on the far side of the Milky Way, then galaxies are kind of sliding generally in that direction. But they're actually also just expanding. Everywhere we look, galaxies are moving away from us. And really only within about 5 million light years of us do we stand a chance of eventually merging into a larger group of galaxies or into a giant elliptical galaxy. And so thanks to infrared telescopes, we can map out these galaxies that are on the far side of the Milky Way. It's kind of amazing how much of this giant group of galaxies is on the other side of the Milky Way that they've mapped out. And there's very little mystery left about this. There's probably still a few hundred galaxies that they haven't found yet, but they've found so many of them. And as new and better infrared telescopes come along, they map out more and more, and they find more, and we report on them all the time. So like it's like a meme thing. It's a cultural thing, like that these things echo on YouTube for clicks. I don't know. It's weird. And like, I don't mind explaining it. Like, the Great Attractor is a really cool thing, and I love to talk about it, right? I don't mind. It's fine. But I just wonder why the information isn't getting out there. The counter to, we don't know what it is. Could it be a vacuum cleaner that's sucking up galaxies? No, we know what it is. It's just gravity. Again, Evo, totally not on you. It's on the people who are not doing their homework or not staying up to date as they're describing things in the current state of astronomy as we know them, right? It would be like talking about football and talking about the state of the game as it was in the 1980s and not noticing that new Super Bowls are being won every year or something. I don't know. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, what's the current state of lava tube exploration? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you everyone who put your questions into the YouTube comments. Everybody who joined me for the live show. There is now the next live show is going to be on Monday, January 16th at 8 a.m. Pacific time, which is going to be 11 Eastern time, and then early evening for folks in Europe. So we've got an event here on the channel, but we sort of rotate when that live stream is each week to give different parts of the world a chance to participate in the live event. So I'm going to shout out some astrophotography channels, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finger, David Giltonen, David Matz, Evan.pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Buck, Rankaidu, Richard Williams, Sean Sargent, Stephen Fathermunley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So as you know, one of the things that I like to do is try to shout out channels that are trying to communicate space and astronomy, especially the ones that don't have a lot of fans. And so I've been digging and digging through YouTube to try and find more of these channels. And it's really hard to do, because if you search for the kinds of topics that people who want to communicate these things will be wanting to talk about, then you get slop. And if you like just sort for the newest videos, then you really get slop. And so what's cool is that there aren't a lot of slop astrophotography channels. And so I could do searches for various topics in astrophotography and turn up a bunch of channels. And so I wanted to share a few that I found this week. So first up is Astro AF, and this is by Doug, and he does a ton of like gear reviews and how to use your software and how to do image processing stuff. But one recent project that I thought was really cool is he built a pier in his backyard. And if you're a serious astrophotographer and you have to go and you have to set up your telescope every night, having a permanent pier that you can just use and have your telescope sitting on top is great. And so if that's something that interests you, it interests me for sure, definitely check out his channel. And he's only got 1,680 subscribers. So let's make that more. Next up is Maximum Astronomy, and the guy who runs this channel, his name is Max. And then again, same thing, tons of videos about gear reviews, the different telescopes that he uses, and he goes through a lot of the fairly recent smart scopes. So if you want to see his opinions of the Vespera and the Unistellar and all the other smart telescopes, he's had a chance to work with them all. And he's only got 8,280 subscribers, so definitely make that number go up. And then the last one is Frost's Astrophotography. That's a tough one to say in English, but I guess Martin, who is in Sweden, that's easier for him to say. He is fairly far north, and so he has pretty nice dark skies and has like a lot of really beautiful pictures. sequences that he's taken and gear reviews. And the thing that's kind of interesting is he's been doing a review of using a C-Star S30 Pro, but then pulling the raw images off and then using those in something like PixInsight to actually do some post-processing without just letting the AI do the processing for you on the telescope, and sort of compare what somebody who has the right tools can pull out of an image compared to, say, what the telescope is going to try to do for you automatically. He's only got 3,470 subscribers. So again, let's make that number go up. All right. Please, as always, if you know of channels which are trying to do actual, genuine space and astronomy, even science, I'll take geology, outreach here on YouTube, please let me know, especially the ones who don't have a large following and we can really help them out. All right. We'll see you next time.